Uh, Good morning, all audience, delegates, experts, and the council chair members. Today, we are here gathered for the expert lecture talk by Mr. Nandan Mishra on the process of innovation, development, technology, readiness level, and commercialization of lab technology and tech transfer under the Institution Innovation Council PSIT Kanpur. So basically, this innovation is run by Ministry of Education, Government of India, to basically motivate the young expertise to come out with their innovative ideas and similar kind of research innovations to motivate our youngsters and also help us out in adult ranking scheme. So a brief about Mr. Nandan sir. He's a founder and CEO of Algo 8 AI since 2016. Sir has been co-founder of the Deep Spatial and Scalable Geospatial AI listed on CSC Canada, leads AI and partner at the Predict Medics Incorporation, Toronto, Canada. And he is a currently founder of Prithvi AI, run under IIT Kanpur. Sir has an analysis for the business strategy and has along with the satellite data analysis at ISRO. So I request Mr. Nandan Mishra, an alumni of IT, to enlighten with their great experience and their title to come up with their new ideas and encourage our delegates and students. Thank you, sir.
Thank you, Dr. Singh. Thank you for your time. And think, yeah. So, okay. So what we can do is that I'll just post some questions for you, and what I'll do is I'll try and join in from the other part as well because I might be using. So, can I just get to know who all are the participants, what is their background? Just to, you can just use the chat window to tell me where are you joining from and what is your basically background. You're a BTech, MTech, second year. Just start typing your, I'll be able to see the chat window. So I can put my name. I can put I am Nandan Mishra, joining in from, right now I'm in Noida, and yeah, so so you can just put your name, and maybe, or you can just put the place from where you're joining in and your background, your academic background. Just put that here on the chat. Is it possible for the participants to just do that? Guys, are you there?
Yes, sir. Yes, sir.
You have to send the chat. Yeah.
I'll cooperate with Dr. Raghuraj, sir. Do let me allow to participate the students for the open with the chat box. Let me ask
please,
the same, sir.
Because if it is not an interaction, then it will become one-way Gyan session, which I don't want to do.
Sure, sir.
Yeah. Yeah. Are you guys able to put it? Guys, are you able to use the chat window? Okay, BTech second year PSIT. Now Anuj puts it that way. Who else is there? Please go ahead. I can see one response. Anyone? Second year CSAI, okay. Second year PSIT, okay. Then Abhinav has put in, Suyash has put in. BTech second year Vaibhav, Akarshan, Akarsh Sachan, second year. Anusha, BTech CSE PSIT, okay. Who else? Sanchit, BTech second year. Abhishek, Agrima, Akarsh, okay. Akarsh Katiyar, Saksham Gupta, okay. So largely all are BTech second year students, right? That's what I get, okay. Okay, great. And use this window to talk to me, okay? Whatever you want to say, huh? Consider this like an open mic, huh? So my first question to you, okay? I'll just okay. So my first question to you, hi all, how are you? Can you tell me what do you think is research? What do you mean by the word research? Yeah. Yeah, any answers? I cannot see any answers. So my first question, did you get my question? Something and searching thoroughly about a topic or anything. So what are we searching, or why are we researching it? What is the objective of research? Yes, it is a detailed study of something, but what does that research lead? Yes, to get more knowledge. Yes, correct. So research objective is to create more knowledge. Okay. And what do you think is innovation? Can you tell me what is innovation? Yeah, innovation is creativity. Okay. What else? What else? Modification in existing ideas, new ideas. Okay. 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 Mm-hmm. Okay. Is coming out from on new. So what do you think is the difference between invention and innovation? I'm trying to write it on the screen. I don't know if you're able to see it. So what is the difference between innovation and invention? Reusing it in, okay, I get that definition. Okay, what else? Is it? So ideas are coming out to be very important, but so I'll give you a very interesting thing. So is research linked to innovation? My next question is this. So you defined research is about creating knowledge and innovation. So is research linked to innovation? Hello. Innovation is modifying and invention is discovering. Very correct, Anusha. So invention is completely new. Yes, correct. Very true. So incremental improvement in the things. Okay. So that is one difference between innovation and this. Okay. And since today's topic is more about, I think, process of innovation development and technology readiness level and commercialization of lab, I will talk about this. Okay. So we got it that research is about creating knowledge. It could be generally research is focused on creating new knowledge about something. It cannot be about some old knowledge. It is about discovering new knowledge, and that's why you are doing research. And then basically applying that knowledge to create benefits or create incremental benefit is innovation. Okay. So are you getting my point? So what is the difference between research and innovation? So research is about creating knowledge and innovation is about applying that knowledge. So without knowledge or without research, innovation cannot propel. Okay. If you will do innovation on without research, then it will only, when it is not innovate, when it is no new knowledge and you are just using your past knowledge to basically improve something. What is it called? There's a Hindi word for it. हाँ बोलिए. Hello. Hello. Somebody said something. Yeah. When you are not using any new knowledge but are still innovating, what is it called? No, no, of course it is innovation, but what kind of innovation is it? There's a colloquial word for it. It is called jugaad. Jugaad suna, jugaad shabd. So what is jugaad? Jugaad I don't know. we already have. Okay, existing knowledge, that is basically as is innovation. Okay, what is that common sense that can be applied? That is jugaad, right? What is that existing knowledge that can be applied? That is as is innovation. But what is that new knowledge that has to be created and applied? That is basically the innovation aspect of it. That is basically the research based innovation aspect of it. So there is a difference between the two. Okay, now I'll go into the process of research and how do you basically innovate for research. Okay, so there is a very interesting concept. Yeah, is there any question from anyone on the till here? Everybody is getting what we are saying? Hello, any questions till now? So are we, yeah, okay, great. So my next point that I would like to, just give me a moment, I'm just trying to log in through my tab also so that I can draw some few things for you. I'm just trying to do that as well. Would it be possible for you to let me share my screen? I think you have allowed it, right? Okay. Trying to. Okay. I was just trying to actually get my tab in, but I think there is some technical glitch because of which it is not happening. So to give me some time. Hmm. Okay. Okay, guys. So I'll just basically take it because of the lack of tools. I'll something very interesting, which is called the technology readiness level. Okay. So have you heard about this term TRL before? Technology readiness level. No. Okay. So I'll give you a practical example. So how many of you have used Zomato or Swiggy? Everyone, right? So can you tell me that when was the first time you used Swiggy or Zomato? Can you tell me the year? Just type in the year in the chat window. Hello. 2018. Okay. And when was the first time you used Google Maps? Okay, that was 2020. Amna. Okay, that's quite late. I hope that Google Maps existed in 2014 because I was a part of that team that did the traffic API thing, right? So when was the last time you used this thing? Okay, no problems. So okay, 2017, correct. So see, what has happened is that when these technologies were initially introduced, okay, which you see them now, okay, their shape and form has changed, and that transformation is brought about by improving the readiness level of the technology as it is being built. Okay, so when you launch something, it might not be in the very purest form as what you see today, but it gets improved. So there is a logical framework to think of how technology has to be built. Okay, and I'm going to share a framework with you in which you can define any new idea which is at a concept stage. Okay, and basically build onto it logically to take it towards a launch. Okay, and there is an objective framework to do that. Okay, I'll just share that link with you. My screen? Can you see my screen? Yeah.
Yes, sir. It is visible.
Okay. Okay. Good. So See, what happens is that whenever we look at building new ideas and taking them to fruition, taking them to final product being delivered, we are looking at them at various technology readiness levels. What does technology readiness level mean? As the name suggests, it means that how ready is the technology. Okay, we are measuring the levels of how ready is the technology for usage. Okay, and there are various levels at which you can define them. Now, whenever you, as you said, some of you have used Google Maps, some of you have used Swiggy. When they initially came, they were working on a very basic concept, right? But as it evolved, there are new and new things that are coming in them, right? So any new thing that you want to do in this world, you will have less technology uncertainty on, you will have more technology uncertainty on it in the beginning. So whenever a new idea comes up and say 10 people, 10 simultaneous teams start working on that idea, then the uncertainty is much larger. And then as people start working, people start learning from each other and the uncertainty gets reduced. So the readiness level of technology increases as the uncertainty of the technology gets reduced. Okay. So we are looking at readiness level as an account or a measure of how uncertain is the outcome of the technology. Meaning that the technology, agar wo, if it is available for use, there is a high technology readiness level. If the technology is still at a concept stage, it's a low technology readiness level. Okay. So with these definitions, we will look at some of the definitions and how TRLs have been written. Okay. And this is applicable to all hardware, software. And how did TRL come into being? TRL was initially used by NASA, which is the National Aeronautical Wala, jo aerospace wala hai, space agency, where basically they were using it to define and launch a rocket, right from idea stage to launching the rocket. The entire measure of innovation could be measured using the TRL framework. Okay, and based on the TRL framework, you can define where you are in your innovation pursuit and how far are you from making it available to the users. If you can use technology readiness level as a measure of your software, then you will know absolutely what you have to do. Okay, you will know absolutely what has to be done as the next step. Okay, so that's what I'm going to tell you. So for example, we will take one example. Okay, we will take one example of one software and we will see how it has moved from technology readiness level 1 to 9. So which software do you want to take up? You can tell me. It should be a software that we all know. Okay, I can give examples from my thing as well, but might not be relevant to you. So that's why I want to basically talk about any software that you think. We can talk about Google, we can talk about Facebook, we can talk about uh, we can talk, I think somebody has written VS Code. Is everybody aware of VS Code? Actually, yeah. Is everybody aware of VS Code? What? Hello? Are you talking about Visual Studio? That's what I can get. Okay, okay, cool. Fair enough. So I would actually not take up such example like that because it is a software that you guys are using to code. It is not being used by a user. Okay. So can we take another example which is more like a digital tool like a Google or something like that? Maybe we can take up Word or Microsoft Word also. We'll take up Google. Okay, I'll just give you the example of Google or Google Maps, whatever you want to, because I have also experienced and it's being used. So I'll just take that example. Huh? So can you tell me what is the basic principle behind Google? Uh, any of you? What is the basic principle on which Google works? Yeah, any answers? Search engine. So what does a search engine work on? Hello? Yeah. What is the basic principle for a search engine? It searches various queries, but what is the basic principle around which the search engine works? sorts the relevant data on internet for user. Now, how does it do that? So let's Google that also, huh? So just Google what is the basic principle of search engine. And tell me here on the chat window. Web crawling, correct. But web crawling is not how Google works. Web crawling is the data input to the Google engine. So you can look upon something called the automata theory. What? The automata theory. Okay. Are you aware of this word, automata theory? Okay. So automata theory was given by somebody called Rajiv Motwani, who was the mentor of Larry Page and Sergey Brin. Larry Page and Sergey Brin are the founders of Google. Okay. And Rajiv Motwani was a guy from IIT Kanpur, computer science, who was a professor in the university in which both of them studied. Okay. And he gave what is called the automata theory. In terms of research citations, it is the most cited paper in computer science history. Okay. One of the most cited. Okay. So, so automata theory is the basis of the Google. What it says is that okay, relationally, if I can define relationally the entire thing, these words, then there is a way I can search them through. That is the basic principle behind Google. Okay, so you can look about automata theory, you can look about research, you can look about what Rajiv Motwani did, and that was the basic principle behind it. Now, when you move from basic principle, the basic principle is that, okay, if I have two linear bases, if I have one basis of information which is defined in some dimensions and the other basis of dimensions, how are they interconnected? I can build a linear algebraic or a linear or a non-linear relationship between them. Okay, so that is one way of doing that. The second is basically the technology concept and application of it. Okay, when you say that, okay, this is the basic research or the basic principle, and on that I am building an application. Let's take another simpler example. You guys are all from computer science, so I won't take a mechanical or a chemical engineering background problem, but let us take some as basic thing as you have all studied history of computers also, right? So what is the basis of what was the, if you look at Charles Babbage's engine, what was the basic principle of computing there? Any answers? That what was the difference engine or what was the analytical engine that he had built? What was that? You must have heard those terms, right? Okay, so in short, what I want to say is that there is science, which is the basic principle that is observed and reported. Okay, so scientific knowledge generated underpinning basic properties of software architecture and mathematical formulations is the TRL1. Whenever we look at a problem, we want to define it in terms of mathematical formulation and software architecture to it. Okay, so if we can have a mathematical formulation and a software architecture to it, it is the basic principle on which the entire thing is working. Now, as we move on that, the technology concept or application is formulated, where we are looking at the practical application is identified, but it is speculative. It means that no experimental proof or detailed analysis is basically available. There is no evidence that it would work or not. We know some basic characteristics of the algorithm. We know some basic principles on which it is to work, and we basically code that and see that, okay, this is working. Okay, so there is a very, very big assumption in the entire practicality of it, in the application of it, but the practical formulation, meaning in life, how it is going to take place, we are able to create that. Okay, then there is a TRL3, which is the analytical and experimental critical function, where we are now looking at how the limited functionality to validate critical properties. Like now we have to see that, okay, we have say 4 parameters. For example, let's take the example of back of Google. Okay, so we knew that, okay, automata theory is the theory in which it will work. Now we say that I have 2 pages of unstructured text, and I want to search them through. Okay. And I want to basically build an algorithm that will search them through. How will you do that? Okay. Can you, okay. So you are, once you go through the automata theory, you will know how that can be done. Okay. So then you will see that, okay, I will say that, okay, every text will, or every sentence will have a certain amount of metadata if I have lot of documents. But if I have less documents, I will go and see basically that, okay, what is my pattern, or what is the level of words or the spelling or the alphabet. We'll come up with that and we'll write a basic property of the algorithm. Okay. Then we will say that, okay, our proof of this, or our analytical or experimental critical functional of this concept, how will we demonstrate this, is by designing something called POC, proof of concept. Okay. So the proof of concept is actually at a TRL 3 level. Okay. Where we are looking at whether this technology will work for certain functionalities. We say, suppose I enter a word I enter a word and it basically searches in 2 documents, or it searches in 100 documents. This is my POC. Okay. I have built an algorithm that if I search in 100 documents, it will give me the result. Okay. So that is my TRL 3. Now what is TRL 4? We move from 100 documents. We start seeing that, okay, right from my UI where I put my search to the middleware where the algorithm is received and where the algorithm works on the data, to the output that I get on the UI. This entire thing at a level of components can be seen. This is TRL4. So you are moving from a POC to components. So the first level was where basically you just had scientific knowledge. Second was where you had scientific knowledge, you were able to formulate it mathematically. Second level was where you were saying that, okay, what will this science be applied in a practical scenario, come up with that practical scenario. Third is develop a proof of concept. Fourth is develop the various components of the concept. Okay. Shuyesh has asked that if there is no metadata. So we have to look at it. What is the meta? When did the concept of metadata come in? That's also a very important thing, Shuyesh. So initially, if you read this theory, you will find out that there was no metadata that is required. When the size of the documents increase, then the metadata makes it much more efficient to search. That's why you require metadata. So initially, you don't require it. You're correct. Now on TRL5, when we move to TRL5, so we move from component. Now we are looking at the end-to-end software elements being implemented and interfaced with existing systems. Meaning, I am able to load the file of my search engine on my device and basically run it on a data environment or on a test environment or a target environment where I am seeing that, okay, relevant test environment is there, relevant performance is there, and the operational performance of the entire software can be observed. Okay, you might have seen that if I search, for example, this big word, or if I search a combination of words, it is returning the amount of time it is taking is this much. And if I search one word, it is searching. So I am able to see how my software is operating, and I am able to measure key data around it. That is TRL5. Okay. Then we move to TRL6. We are now looking at realistic problems. Realistic problems mean that I have taken it out from my system where I am working on some limited data, and I have taken it up and I have put it on a say on a server and made available to say 100 users, and I am asking them to just use it and tell me what is the impact or what is the value that they are getting from it. Okay. Then the last part is basically the TRL7. From here we start releasing it in the market. So if you will look at our labs, we work till TRL6 with students and professors like you, and then them to the lab by finishing them up. Okay. And that is where we come in and we basically start working on the key functionality which should be available for the demo. We start integrating the entire hardware software for the demo, and we start removing the bugs that might be there in your coding. Okay, this is TRL7. Then we move to TRL8, where we are looking at that the all software has been thoroughly debugged and it is fully integrated, and the operational hardware and software systems are all together, and user documentations, training documentations, maintenance documentations, functionalities, everything are coming into play. Verification and validation has been completed. Okay. And finally, when all the software has been thoroughly debugged and fully integrated and operational systems are existing, all documentation has been completed, sustaining software engineering support has been put in place, then the system is fully integrated and ready to operate in the operational environment. Okay. So you move from a basic scientific and mathematical formulation to basically a practical application, to basically building a POC of the entire thing, to basically moving to a key functionality or components, to basically further building the components and building an end-to-end layer of how it will work. Then you move it to the actual realistic scenario. Then you basically move to the real and you start removing the bugs. And then when you start removing the bugs, you have a fully debugged tool. And then when you have done your verification validation, you launch it in the market. This is how the entire TRL works. It is very different from an SDLC. Why is it different from an SDLC, and where it is same from an SDLC? All of you must have studied or will be studying SDLC. Is because there is an element of uncertainty that has to be handled. Okay. If I give you a simple software that, okay, you have the data here, you extract the data here from here. In fact, all the tools that exist today, except Google or except some of the tools which are using some natural language or computer vision or these, there is no element of technology uncertainty there. There is a very high technology reliability. If I write this code, this is going to happen. But when research gets mixed with it, when you're trying to make new knowledge and then put that knowledge to innovation, this TRL framework works the best, because you have limited knowledge, you do this much research, you get that knowledge, you apply that knowledge to build something. Then you use that to create more knowledge, and then you basically do further apply it. Then you further research on it, create more knowledge and further apply it. This incremental process, that's what I wanted to draw using my tab also, that this incremental process of building some basic stuff, then building on top of it, then building on top of it, then building on top of it, is the most best way. The closest the closest approach that works to this is actually the agile environment, that is the user-centric environment that many companies work on. But there it is more about the functionality tweaking. It is not about the technology tweaking. Here we are saying that a new technology can be built. You think of AR VR, we can build AR VR in this way, right from the basic. Now, what will happen is that as the technology landscape of that particular technology improves, you will have components available at TRL4. Okay, so you will know that, okay, if I have to build an AI program, I have to use maybe Sophos for this particular data extraction. I have to use this for this. I have to use this for this. I have to use this. Then, but how you are basically building any new technology, which is not happening in India. So how many in India have built, except Postman? I like Postman a lot. Except Postman, there has been no new technology development in India. If you guys are aware of software coding, tell me a new language, or tell me a new algorithm that has been developed by us, which is being used so by companies. No, that is what our company does. At least I can tell you that we have got 17 algorithms that are being used by companies. Okay, and people pay us for that. So when you are looking at developing technologies right from the basic scratch to where it has to be implemented, that is where this technology readiness level will be much important as compared to the traditional way of SDLC or traditional way of Agile. So it is the lab that we are going to set up at PSIT, you all will be exposed to taking a concept and taking it at least to TRL6, or at least from TRL4 to TRL6. We will initially focus on TRL4 to 6, because that is where the maximum technologies die. Maximum technologies die there, because companies have limited budgets to focus on them. And second is that there is no real talent. You have professors who can work on TRL 1, 2, 3. You give them, they will say, okay, this is the problem, then this can be solved using this theory and this mathematics. Okay, and in practical application, this will be how it can be done. And maybe the limited functionality will look like this, the lab environment will look like this. But once it starts getting out of the lab and still it has not reached the market, this TRL 4 to 6 is the most critical thing. And that is what we call as research translation and innovation. Meaning research has been done to create some knowledge. We know something about it, but it has not been created into a product. It is not TRL 7 where I can see a prototype. So building prototypes from basic research is what you guys are going to focus on. Once you start getting this is how the entire innovation works back in, you on COE, you look at Google COE, you look at, I like these companies a lot. These are one of the best in terms of their technology implement. Amazon ships up an update. Do you know how many times, okay, a trivia question. How many times Amazon updates its software in a day? Come on. How many times does Amazon improve its software in a day? Smart people will Google and tell me. Yeah, how many times Amazon updates its software in a day? Okay, the answer is 30 updates in a day. Can you imagine? The code is so dynamic, you know? Anyone? Yeah, the code is so dynamic that they are updating and integrating it at that level. It is so modular and it is so dynamic and it is so continuous. Okay, that the improvement on the software is happening, and they have complete data on the user as well, on which they have put AI, which is giving them knowledge to further innovate on the product. Okay, so that is the kind of updates that come on Amazon. Okay, the sites might say 30, might say 15, might say 10, some might say 40 also, but the average is around 30. I've talked to somebody who's there, and that's what I'm telling you. Okay, off record. Similarly, Microsoft, when you use Excel, they are now tracking your entire behavior there. Microsoft Excel, especially online tools. Okay, they built a complete research center of excellence that is basically focusing on building new prototypes and taking them and launching them. Even some of you are the guinea pigs of it. So some of you might see certain functions. If you sign up for Microsoft test process, you will know that you use Excel, then they are going to take your data and basically improve it and give you new tools or new suggestions on your Excel. Okay, so it all focuses on this. The first three is basically the formulation. This is the roadmap that you can create, research roadmap. 4 to 6 is the translation of that roadmap to prototypes. And then 7 to 9 is prototypes being translated to products. So we don't expect you to develop full-scale products, but we want to work with you on developing prototypes out of basic principles. And all of you are fully equipped to do that. Okay, so we will be teaching you how to think this way and how to build this, and we will be available as mentors to do this. Now, since we have like around questions and answers, please ask me whatever I have told you on. Can you any questions that you have on whatever I have told you? Please go ahead. I refrained from speaking about AI today. I refrained from speaking about what my company does. I wanted to just talk to you about this. Okay. Any questions? Can we have an open mic by any chance, sir? Can we open the session to all, and can they speak to me? Hello.
1 second, sir. I'll incorporate the same, sir.
Sure.
Yeah, student, you can unmute. If you have any query, you can ask.
Yes, please ask me. So did you understand what is TRL 1 to 9? What is the basic philosophy of building incremental research, building incremental innovation on that research, and then improving on that? It's like a loop. Okay, you research, you create knowledge, you apply it, innovate, and then you again research, innovate. This cycle has to complete 9 times before an actual product comes into being. Okay, from a basic idea. Product, it moves from idea to firstly what we call as a POC. Then from a POC, it moves to a prototype. From a prototype, it moves to a product. Okay, so you can remember these 3 P's: POC, prototype, product. The more POCs we have, that's how the good the research is. The more prototypes we have, that's how good the research translation is. The more products we have, the more innovation is there in the lab. So we are here to build more prototypes working with the professors, working with on basic ideas, building POCs, and then translating them to prototypes through you all, right? So that's what we want to do. Is it clear? And any questions on this? Any doubt on this? See, many people think that why is this needed? हम simply अपना coding, competitive coding, etc. सीख लेंगे और उसके बाद हमारी नौकरी लग जाएगी. आजकल तो 30 lakhs की भी लग रही है, Goldman Sachs और सब में. That is also great. Okay, by the way, it's not bad. Huh? But उसका जो increment होगा ना, वो 30 से 35 जाएगा, 40 जाएगा, 45 जाएगा, हो सकता है 60 चला जाए. लेकिन यहाँ पे क्या है, ये जाएगा आपका. This is huge. This go to an average data scientist who's very good and who's able to do this can earn around 300,000. What I am saying is this, that you guys should focus on building new prototypes, okay, from basic POCs. And that's the level of technology temperament that we want to bring on the campus. Okay. Any questions, guys? I'm super excited to ask, to answer your questions. Working, so kuch aaya hai. Working on TRL frameworks can also waste our time on building a product which is totally made. Why not we build on our product from that knowledge? No, it's a good question. So whether the product will waste, whether it will waste your time or not, is a function. It's actually a deterministic question. It's not a probabilistic question. Okay, so it's not a, it can be future to present determination that can answer this question. Okay, so how you can answer is the following. You have to look at what the user requires, and you have to absolutely integrate with that user. For example, the user requires you to search vast databases, okay, but the technology that you have right now can only search 3 documents or 10 documents or 100 documents. So this means that there has to be new research done on building this. So in the end, the customer is the king, the user is the king. If I have to build this tab, I have to build this tab that is basically has got a, this material that can conduct the same thing as my nails or as my hand. I have to build this material because I know that the user experience that I've created. So the user experience is guiding me whether that research is needed or not. But how that research has to be built, because correct. From a financial management standpoint, I will be very frank with you. When a company looks at innovation, what we do it is this way. We look at TRL 1, 2, 3 and we give it to professors to work on. Okay. We give students the chance to work on TRL 3 to 6 and then we work on TRL 7 to 9 ourselves, because the maximum funds should be spent on translating what we have already, as what you said, Suyash, right? But TRL 7 to 9 is actually cannot happen without TRL 1 to 4. The reason why we are lacking as a country is because of this. We are not able to translate that 1 to 6 and then basically that 7 to 9. Most professors in across, and I am studied at IIT, work on 1 to 3. They don't want to work on others. The problem is that the entrepreneur is looking for some 7, 8. Because the entrepreneur is saying, yaar, mere paas paisa itna hi hai, I want to spend this much money. I as an entrepreneur realize that. But TRL 1 to 3 professor will say, no, yaar, I want to stick to my academic research and I want to tell कि यार ये problem ऐसे solve हो सकती है, ये problem ऐसे solve हो सकती है, ये problem ऐसे solve हो सकती है. But what connects this research to this innovation is this research translation that I told you. And the guiding path for this is TRL 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Any other questions? Entrepreneurs don't only have business knowledge. Entrepreneurs can be very technological. I myself have patents, right? So, and I am a CEO. My CTO is separate. Still, I have patents. So, in fact, Larry Page and Sergey Brin have got patents in their name, and they were excellent software engineers before they were entrepreneurs. I think if you take off example of Elon Musk, then he's an excellent first principles engineer. I think he's by far the best. He would have written the best, one of the best PhDs, I think, had he not left it. He was a PhD dropout. So no, entrepreneurs know a lot of technology. They also know how the technology can create value and what to charge people on. So for example, if I cost me 70 lakh rupees, I might not charge them 140 lakhs, which is just 100% profit. I look at how much value am I creating for them. So maybe I'm creating, the value that I'm creating is $3 million. Then I would like to charge 10% or 20% of that. So it will be around $600,000. So my cost was 100,000, but if I am able to link my 100,000 to the value that I'm creating through that, I might be able to price it better. So the entrepreneur needs to know technology. He needs to know the business he is in, the value that he's creating, and what to charge for it. Both, all the three. Yeah. Any other questions? I see only Suyesh being so active. Other people? Okay. There are quite a few people, 93 people. I would like to have more questions. Okay. So if you will not ask me question, then I ask question, and then it will be a dumb silence because you will not answer it. But I'll ask you still. So what did you get? What did you get as the meaning of TRL? What is technology readiness level? Hello. Hello. Okay. So I'll just revise it for you. Technology readiness level is the readiness of the technology from the perspective of it being used by potential users. Okay. It is moving from technology readiness 1 to technology readiness 9. And 1 is basically science. 2 is basically, I am saying, practical application. 3 is POC. 4 is component. 5th is basically integrating the components together. 6th is the lab environment and complete functionality. 7th is taking it out of the lab environment and working on actual environment. 8th is removing the bugs and making it totally integrated. 9 is launching it in the market. These are the 9 levels of technology readiness level. Okay. If you are able to integrate all these 9 for any new technology, you can launch any new idea in the market. You think that we don't suppose pollution is a big problem, okay, and we say that pollution, so we have to look at the science behind it, and we have to mathematically formulate and write down what is the root cause of this. Okay, if it is vehicular pollution, then maybe measurement is the most important thing, right? Then if it is basically industrial pollution, then what is the level of measurement we have? So you have to define a model that these are the sources which are generating pollution, these are the solutions which are lessening the pollution, and overall the pollution problem is like this. Then you have to move further and you have to say what is the practical scenario. Let's take the example of Kanpur, that what are the sources. Then let us take the example that if we put sensors here and there, then we will get this. So that's the POC. Then we move to the sensor, the dashboard, and this then becomes the component. Then basically we move from the component, we say that, okay, this is what the dashboard will look like. And maybe a dashboard will be with the DM, one dashboard will be with the CISF, one dashboard will be with each industry owner, one dashboard will be available for public on the today, how much carbon footprint did they create. Then maybe one part of the problem will be this parali that people basically this agricultural fuming that they do. So how do we measure that? Maybe we can use satellite data to find out whether that can be done. So this way you can think of the entire problem and then start building components such that things become usable. Okay, there are many examples in healthcare, education, agriculture, livelihood, examples in fintech, examples in manufacturing that we do. All these examples can walk you through from TRL1 to TRL9 in a very logical way. And that is the way it should be approached, most logical way. Okay. Any questions, or we'll end up in like 5 minutes? Professors, if there are more professors on the call, they can also ask me questions. Yeah. Professor Singh, if there are no questions, then we can end it. Professor Suryavanshi.
Yeah, sir. So fine, sir. The lecture is so nice. So we can end. So thank you,
Sure,
sir,
sir.
for giving us valuable time from your busy schedule and share your ideas about TRL.
Thank you. Thank you.
Sir, I just want to share that all the students are from the computer science branch. So I
Right.
hope they will get motivated and use your idea to think in the direction of a startup and entrepreneurship.
Correct. Correct. Because
Yeah, sir.
today it was more about process of innovation. If it was to do with entrepreneurship, I'll talk it in a reverse way. So an entrepreneur has to look at value creation first and then link it to technology.
Yeah, sir.
But as
So-
a technologist, you have to do it the other way. Yeah.
Yeah, sir. That's why we picked the second year audience, so they will get motivated and select the project which suits.
Yeah,
for this
I would
startup.
love to. I would love to work with them on these technologies, and I would love to suggest them the ideas on which they should work. I have built 3 successful companies. 2 of them are publicly listed. 20-30 million dollar exits out of them. So I would be happy to talk on those lines as well.
Sure, sir. Sure, sir. Sure, sir.
Yeah.
And thank you, Sailen sir,
Thank
Dhanesha
you so
sir,
much.
Prerna ma'am, Rajat sir, for coordinating this session. Thank
Thank you,
you
sir.
all participants, and once again, thank you, Nandan sir.
Thank you so much.
Definitely we will have
Pleasure
more
always to
lecture
interact
of
with
you. Okay, sir. Thank you.